Да, Егор будет, он уже выступал у нас на первой конференции Kyiv Upstate и рассказывал про интересные штуки, про то, как, почему continuous integration не нужен. Вот, и сейчас он расскажет свой новый доклад про себя. Поприветствуем.
So I'm gonna, 1, 2, 3, yeah. So I'm gonna speak English. I'll try to, try to speak slowly so you can understand me and I can understand myself too. How many of you here are writing code every day? How many programmers are here? I just want to understand the room. All right, that's good. I'm a programmer myself, and the subject today is if you need robust software, make it fragile. There are two words which not probably everybody understands, and I'll have to clear them up. The first one is robust, the second one is fragile. Robust is, when it's in Russian, I think it's the clearest translation is, I think, stabilny, something like that. And fragile is хрупкий. So if you want to make your software stable and able to work, my point is that I will try to prove it, that we need to make it fragile. So we need to make it possible to break quite often and in many, many places. That's the translation of the words. I just have 12 slides, so it's not going to take long, and I expect questions afterwards. Now, while you're following me on Twitter actively, I'll say a few words about who I am. So I write code myself. I'm an architect in over 20 projects, and I do work with software which fails sometimes, and I do work with real projects. So what I'm going to say later today is not just an abstract theory. It's a practical experience which I'm going to share with you and try to convince you to follow this idea. So that's me, that's my name, that's my Twitter. Follow me, and you'll get more ideas. So now to the point. So the robustness, as Wikipedia says, is our ability, the ability of software to continue operating in situations which are not normal. So when something happening which was not expected, the software needs to continue to operate. This is what we all want, this is all we want need. So we want our mobile app, or a server, or a system, or a web system, or a microservice. We want it to continue even when the situation goes wrong, when somebody provides some wrong data, or we have a disk full, or we have some, I don't know, probably the mismatch of the formats or something like that. So we want to continue, we want our software to continue working. We don't want it to break. We don't want it to break it in front of the customer. So we don't want to see this stack traces we don't want our customers to see the stack traces. We want our software to be stable. That's the goal. But in order to achieve this goal, most of us, most programmers, do it the wrong way. So in order to achieve this robustness, we go this way. And this is the practical Java example. There are so many programmers here, so you, I think, should understand. So let's say it's a function. I'm not going to show too much code. This is probably the most important thing. So let's say it's a function which calculates the size of the file. So we give it a file, and then this function, this method, has to calculate how big is the file and return the value. Let's say the file doesn't exist. So some of us, and this is the wrong way, they will do, if file doesn't exist, it just returns 0. And this is one approach in order to achieve robustness. So the software, the method will continue the execution. The file is not there, it's not a problem. We want our software to be robust. We want to continue operating under abnormalities, because this is an abnormal situation. We are not expecting our method, well, it's not really normal, right? The method is called, it's supposed to calculate the size, but the file is not there. So this is not normal for me if I'm the method. So I'm expecting a file from you. You give me, instead of giving me the real file, you give me something which doesn't exist. And you expect me to calculate the size of it. So this is not normal. But I want to continue. I want to be robust, right? I'm the software, so I want, like this was before, like we said, robustness. So I want to continue operating under abnormal situation. And I'm doing this. I'm returning 0. This is one approach.
It's clear, right? The code is clear. And this is another approach. So what I'm saying, my point is that this is very wrong. This is totally wrong. This is the bad way to achieve robustness. And this is the right way. We check with the same method. So calculate the size of the file. And then I'm saying, if the file doesn't exist, I'm not going to continue. I'm going to break right here. I'm not going to try to survive. I'm going to break the code now and show an exception. So this is counterintuitive. So intuitively, we want to achieve robustness. We want the code to continue. But here we don't continue. We throw an exception. We say, no, we're not going to work like that. We just break. So this is approach number one. This is approach number two. And they are called, the first one is called fail-safe. The second one is called fail-fast. And my whole point today is to say that the fail-safe is wrong and the fail-fast is right. That's the idea. So again, if you want to achieve robustness, like Wikipedia says, if you want your software to continue operating even in abnormal situations, you don't do it that way. You do it this way. Because fail-safe is wrong and fail-fast is good. And now I'll try to prove why. So this is basically fail-safe means that I'm always trying to fail safely. So I'm always trying to be safe. I'm always trying to survive in all possible situations. Fail-fast means if something goes wrong, even something small goes wrong, I immediately crash the entire thing. I immediately break the execution. I stop the execution. I complain about it. I throw an exception. I complain to the user. I basically stop the application. This is fail-fast. So there's basically two approaches. And this is one more example just to show this is maybe even the most typical way how people do the fail-safe way. This is again wrong. This is my last Java example. You've probably seen it many times. So you try to do something may go wrong, you catch an exception, and then you basically print the stack trace and you continue. So this is also known as swallowing exception. So the exception here is swallow. So swallow means blood type. So the exception is swallow. Something happened here. For example, I don't know, disk is full, file is not there's no internet connection, or there's some wrong numbers, wrong in, wrong out, something. We catch the exception, then we print the situation in the log somewhere, or we continue the execution. So the software stays stable, more or less stable, or it's still online. So this is a very typical example of fail-fast, and this is wrong. So basically, now I'm trying to prove and to show why it's wrong. Why I think that breaking the execution and failing as soon as possible in as many places as possible is a good thing, and it will actually lead to robustness and will actually make the application more stable. Before I get there, I have to say that we are basically having two different approaches. In case of fail-safe, we are concealing or hiding the problems. So we don't expose the problem. We get the file in. We want to calculate the size of the file. The file is not there. We don't complain about that. We basically hide the situation and conceal the situation. So we're patching. So we're hiding this. We were hiding what's happening, not telling anybody about that, and trying to survive in any possible way. We just return 0 as a file size. And the opposite approach is revealing. So we are basically making this problem visible to everybody. So we're not hiding, we're revealing. So we're making it visible, we show it to everybody, and we say, hey, somebody just gave us a file which actually doesn't exist. This is the situation which is not acceptable for me as a method size. I don't want to work with this situation. I want to break right here, right now. I don't want to hide that. I want to complain about that. Because it's not my fault. Somebody gave me the file which is not on the disk, so why it's my problem to deal with this situation? Why should I try to save this? Why should I try to help you? Because it's basically your fault. You gave me something which is not a real file. And now you want me to calculate its size. So I want to complain about it. I'm not going to help you, I'm going to work for myself. So this is concealing versus revealing. And now, my proof. I was actually, while preparing this presentation, I was thinking how to prove that, because it sounds very logical to me, but it took some time for me to find actual, real kind of logical proof why it's really that way. And I found a metaphor. Let's say the whole application, the whole software is like a body of a living creature, of me, for example, or of an animal, and it all works together, and it has some elements: a leg, a foot, a head, some elements, and all these elements, they stick together. So in order for the whole organism to live together and to survive and to continue operating, all these elements, let's say we start from, so back to the metaphor. So this is a living organism, and basically then we have a bug, a problem, in one piece of the body. So in one place of the body, we have something which doesn't work properly. We want to heal that, to fix it. We want to cure it somehow. So we want to focus on this element and fix it, instead of training other pieces of the body to live together with this broken element. So we don't want, if one piece of my body doesn't work as expected, we want to fix it instead of teach all other elements of the body how to survive with this broken element. So for the whole body to be healthy, we basically want to find the problems as soon as possible and fix them as soon as possible, instead of training all other pieces to survive with this bad element. So basically when we start the application development, we have many broken elements. This whole organism is not really healthy in the beginning. It has many potential problems inside. Not potential, but real problems, many bugs inside it. And we want to fix that bugs in order to make the whole organism more stable and more robust. To find these bugs, to find these problems, we want to find them, we want to isolate them and fix them, instead of make other elements which are healthy already to live with them. And now back to the code. So let's say this is the execution, the flow of execution. We start from this side and we go, this is maybe, for example, let's say method calls or connections between modules, or it's something. So we start from left, go to the right. Let's say they're all green, that's how it should be. And the size method is one of them. So we basically do something, I don't know, maybe the user uploads the file, and we save this file on the disk, then we calculate something, then we check the size of the file, and then we continue. It looks good. But then we suddenly realize that somebody, some piece of code, which is supposed to give me the file, I'm here, I'm this method side, and this code, this module, is not giving me the right file. It's giving me something which doesn't exist on the disk. So it's calling me the function size, giving me something, my input is broken. So actually it's not me broken, it's him broken, or her. So this is the element which is broken. It's red. But the problem is here. We instead of complain to that element, instead of to say, hey, you are broken, I'm clean, I'm good. I'm just calculating the size of the file. I'm expecting you to give me the good size, the good file. So you're broken, it's your fault. Instead of that, we're doing this. So we're making a change here and saying, okay, if the file is actually not there, if this guy sending me the bad input, I'm not going to complain. I'm going to train myself to deal with this. So it's okay if you give me something which is not a real file. I'm smarter now. I'm fixing the bug because it's a bug, so it's going to be a bug report, something crashed. And then we see, okay, there was no real file. So let's adopt our software to this situation. Let's train it. Let's teach the software not to fail when the file is not there. But let's make it orange now. Because now it has some code inside which makes it accepting the input, which is not really a proper input. So what happens here, actually, is that the disease is spreading over the whole software. Now we have two problems in the code. Now we have original problem, and we have this code which actually makes it difficult for us in the future to reveal similar problems. So we're basically spreading the whole problem over many pieces in our software, in the entire system. Instead of isolating this element, we're letting other elements, we make them more Yeah, and then eventually we'll have the problem here as well. So it will go further and further from one element to another, and the original problem will not be fixed. So let's get back again. Let's say this is the situation. I just created the software. I deployed it to production. I put it online. And then something, boom, crashes. And the customer sends me a report. You know what? I just uploaded the file. Normally I was uploading PDF files. And now I uploaded the text file. And boom, I got a stack trace. So your software crashed for some reason. I'm a developer. I get this bug report. I go in there and I see that in the bug report, I see that the file was not there and the function size basically crashed because it was trying to get the file size of something which doesn't exist. What do? I don't see that, I don't go there, I just fix the problem. I don't look at the real situation, the real problem, why I got this wrong input. Instead, I go to this method, I fix it over there, I put the so-called quick fix or a patch, something which just will prevent me from this stack trace. So the stack trace will disappear. The customer will stop complaining because, okay, now we are more tolerant to the problem, we are more, we're not as strict, we're not complaining that much, so we don't throw stack, like we don't see the exception, the exception stack trace, but the real problem is not solved. So the bug report is fixed, the technical debt is growing, the whole system becoming more, the disease is spreading, and then the whole system will eventually have more and more these quick fixes and quick patches everywhere. So what we have here, speaking philosophically, is we have the tolerance versus arrogance. I'm not sure this is the perfect word here, arrogance, but I think it suits the situation. So the first approach is tolerance. I'm the method size. You're giving me something which is not good for me. I'm tolerant to it. I'm not going to criticize you about that. You're giving me something which is not perfect for me. It's not a problem. I'm not going to criticize you. I'm going to work with you. I'm going to try to give you at least something back. I'm not going to complain. I'm not strict. I'm not strict. This is one approach. Another one is I'm arrogant. So I'm saying, you know what? You do it my way or you don't do it anyway. So I am the method size and I expect a real file coming in. You give me the file, I check the file size. If it's a real file, I return you the size of the file. If it's not a real file or it's absent or something is wrong, I just complain. I just throw an exception. I'm not going to tolerate the situation. So my point is that tolerance will lead to a disease being spread, the disease, bugs, mistakes, being spread all over your entire architecture. The entire software will be full of fixes and patches, and then eventually you will lose the design and the architecture of the whole system. Because you will always be trying to be tolerant to the mistakes made by others. So mistakes are there, they're not in your module, mistakes are somewhere else. And you will be trying to save them instead of being arrogant and saying, you know what, it's not my problem, I'm working on this module. If you're giving me something which is wrong, I'm going to complain. And if you follow the second attitude, if you have this attitude of arrogance, then what will happen is that you will isolate the broken part. And you will never touch this method. You will not try to make this method accepting the bad input. Instead, you will say, you know what, I'm going to complain, I'm going to keep complaining about the wrong file, about the file which is absent. And you should fix your problem. And then, if we do it like this, we will always isolate problems where they should be isolated. So that's the logical answer. That's my logical, my logic of why fail fast is better than fail safe. Is because the fail fast approach helps us to isolate problems instead of dealing with one problem everywhere. So you always put a border around each problem. How do you do that? By following the principle of fail fast. So you always break where you want, where you can break. So every time you see a situation where you can break the code, you can break the execution, you break it. You don't let the abnormality spread over the entire code. You always isolate and say that I'm working with the input I'm expecting. So I'm arrogant, you can say. The Russian translation for arrogant is probably Высокомерный, that's right. So I'm arrogant, so I'm always like full of myself. So I think my way is the way to do it. I mean, me in this case is a method size. So I'm the method size, and my way is to accept the file which exists, and only this is how I'm going to work. I'm not going to make any compromises with you. So you're my client on the left. You're broken. There's something wrong with you. I don't know why you're sending me the file which doesn't exist. Why you're trying to calculate the size of a file which doesn't exist. There's definitely something wrong inside you. This is a bug inside you. So you're trying to calculate the size of a file which doesn't exist. So I'm not going to help you to live with this situation. I'm going to complain, I'm going to be arrogant, I'm going to say this is not the way it works. So this is what I'm suggesting. And now, if we follow that way, I underscore another word, and emphasize another word. So now robustness is the ability to continue operating despite abnormalities. So I'm talking about not surviving, but operating. It's two different things. If you do the fail-safe approach, if you try to always save the situation and not fail, your application will survive, which is not the way it should work. The operating is when the application is like a healthy body, and this is the body which is just trying to survive under stressful situation, and then most of the pieces of the body are not functioning normally. So they are functioning somehow, but this is just surviving, not operating. So I'm trying to say that if you follow the idea of fail fast, and you make your components and elements and methods and servers and files and everything just fail as soon as they can, then your application eventually will operate. It will work like a healthy organism, where in this healthy organism, if some element is broken, the part of the organism is for some reason is in problem, then we just fix this particular problem. We're not going to let this disease spread all over the organism. We fix the problem, we isolate it, and we always fix it in an isolated way. So again, the robustness is the ability to continue operating despite abnormalities, not surviving, but operating. That's what I think is a summary of my presentation. And I think this is the last slide. So what do you think about that? Am I... Give me the microphone.
Hi, I have a question. Imagine Black Friday, a lot of people want to buy something in my website and it's crashed. They go to another website and I lose money.
Yeah, that's true. Yeah, I was expecting that question. So you're saying that we sometimes want to survive instead of to operate normally. This is what's going to happen when you start developing the application. You create the piece of software, you put it to production. In the beginning, if you follow this idea, in the beginning it will crash more oftenly and the application will be less stable. In the first cycles of production, in the first weeks or months. So in the beginning, the stability will go down much faster than it would go down if you try to survive. But then, later, if you continue fixing bugs correctly, then the system will become more healthy and more healthy and more healthy, and eventually your stability will be way higher comparing to the situation if you fail safe. So that's the philosophy. So in the beginning, yes, you will have more problems. It will crash here, there, here, and it will be difficult for you to keep it surviving because you always will try to make the application healthy. You will always focus on the healthier solutions. Like, I'm not going to help this module because this module has a problem. This one is not going to help. Because this one says, you fix your problem, I'm not going to help you. Yes, in the beginning it will be difficult because to fix the problem correctly, you will probably sometimes maybe spend more time. But if you follow it strategically, if it's going to be your philosophy on the long term, the application will be operating. That's my practical experience. Yeah.
Hello, I have a question. When a product lives long and you use different APIs, these APIs also grow and some functions can be deprecated, yes? You put cracks there instead of choosing another API and it continues to work. And in some cases we have a lot of crunches in our product, and my question is how to find out a point where we have enough crunches to choose another API in our product.
So you were saying basically, I wanted to rephrase the question. So you were saying that the technical debt is growing. So you're basically making patches, fixes here and there.
Yes, and some APIs you use in the beginning can deprecate some functions, but you don't want to change API, and you put some another code which doesn't fail and bypass these issues and so on and so on.
That's, I think, yeah. I think that I would say the same. So try to try to avoid this bypassing the problems and basically write it.
My question is, you want to change API for one thing that calculates some small, for example, size, yes? You will put there some косты.
Yeah.
And
hotfix.
Yeah. And when is the point in application?
When it's too many hotfixes.
Yes, when it's too many hotfixes, and we need to choose another API.
Well, as soon as possible, I think. I think in general, these hotfixes, I think it's a bad idea in general. So instead of hotfixes, I would try to. Maybe the question is too abstract. It's difficult to say when. I mean, as soon as possible, obviously. As soon as possible, as soon as you can, with hotfixes. Well, the hotfixes, they lead to technical debt, so we know what it is. The technical debt is growing. We just have too many these ad hoc solutions, like you call them, or solutions for now only. So eventually, we just forget why these fixes were made, and we just have the application is becoming less healthy because it has many patches here and there, and all of these patches are helping us to survive. So it's the same philosophy. If you can break your application now, break it now. Don't wait until you have too many fixes. So break it now. You have one problem, you don't have some function implemented, so break it now. That's probably the answer.
Thank you.
Igor, sorry, Igor, hello. I have a question. Is it the part of the whole system that you wrote in the elegant objects, or it's just separate behavior that we should use in the development process?
Yeah, the question is probably about my book. That was my last slide. I wanted to show you that, you see that it doesn't work anymore. You see, we've just failed. Oh, yeah, I published the book just a week ago, so I didn't have a chance to bring it here. It's not exactly a book about this architecture question, but it's a book about object-oriented programming. So it's kind of a promotion here. I wanted to leave it for the last minute. So there is a book, Elegant Objects. It's about object-oriented programming, mostly about Java. So if you want to read it, just feel free to buy it. It's on Amazon. So, but this book is saying nothing about this fail fast. Oh, there is maybe a few paragraphs about fail fast there. There's one section actually about fail fast, but that's mostly focused on programming. Here I'm talking about in general the architectural approach, not just for one method or just one function, but in general. So I'm saying that you need to make your methods, your classes, your systems, your servers, your microservices, your RESTful APIs, everything should be failing as fast as it can. That's my point here. So the systems should not survive, they should operate. Thank you. Any more questions?
Yes, here.
Yeah.
Thanks for your report. First of all, I totally agree with your throwing exception in size method, but I want to clarify. If we have some page in production and it contains several blocks, and some block that is not critical for this page, it failed. Do you suggest to fail whole page instead of catching this exception and hiding this block and then investigating this problem in logs separately?
That's exactly what I'm saying, yes. Yes.
So
I'm suggesting we need to break the entire page, yes.
I think business never can agree with this.
That's true, that's true. The business will complain, this is the first enemy. Your first enemy is your business. I mean, the business requirements providers. They are not your friends, they're enemies, because they want the product to survive, because they don't basically care about the architecture. They don't care about the future. They care about now, the software has to survive, because they're making money out of it. But your job as an architect, my job as an architect, is to make the system operating so that in the future, it will be easier for me to make it, to be sure that it's robust. So the business is the #1 enemy in this thing, definitely. They will come to you and say, I don't care about your robustness and about your architecture things. All I care about is that the web page does not allow our customers to pay with the credit card. So just make it live again. Put it online. I want to see this page. And you should be strong enough as an architect to argue that, you know what, give us not 15 minutes to fix that, but give us 2 hours to fix this, because this is how we're going to make the system operate. So you're absolutely right. The business is going to be the #1 problem. So thanks for this question.
Yeah, but I think logging was created to solve this problem. When you can debug it, you can investigate, you can solve it, but still business can operate.
Yeah, well, the logging is definitely an important part. You log everything, you log all the problems, you see this log, you watch this log, but when it's time to fix the problem, when you found it in the log, so you see in the log that, you know what, this is the page, like 5 elements is okay, the element number 6 is actually where the problem is. So you were saying, hey, let's just fix the element 6, let's just catch the exception so that we will show the problem here, not on the entire page, but let the system operate at least with something, right? That's...
No, of course, I'm saying that you should resolve the original problem, but later, with logs.
That's what I'm saying. So for now, let it operate, let it survive. So let's fix somehow, let it survive, and later we will fix the problem properly, right?
Yeah, let's hide this block that is
Let's
not
hide. Let's hide, exactly. So I'm saying no. I'm saying no, this is the wrong way. Under pressure, maybe sometimes when your payroll is at stake and you will be just fired if you don't do that, then maybe yes. But in general, if you can, don't do that.
Okay.
That's my whole presentation.
We also have third-party dependencies when something external fails. You also suggest to fail.
Well, yeah, if possible, yeah. Make sure that you also fail if you have an adapter. That's how I understand the question. We have an adapter for the third party, for example, the credit card processor. You give me the credit card, I send it somewhere. There's an exception here, fail over there. So should this adapter fail as well? Yes, it should. It should fail. It should crash the system. Everything.
What if you have sandboxing on iOS, and this sandboxing doesn't allow some great application to fail the OS? So
To fail the entire operating system.
yeah, if you fail the entire OS,
Yeah, let me repeat the question. So yeah, that's a good comparison. That yes, we have an operating system. Operating system does not crash the entire system. Is when one application crashes. So the operating system survives instead of failing. So instead of failing altogether. But in this case, I would say that these elements of operating system, these applications which work inside the operating system, they are not part of the software. They're like third-party dependencies. So in this case, the system isolates itself from broken elements. So I'm talking about the elements which stay inside the software.
Yes, I want to ask you about combining these two methods in one application. So application would run like in buggy ways, fail safe, or in fail fast, or how do you see?
Well, I think so. Yeah, I think yes, because like I said, sometimes we have situations where we just need to fail safe, we just need to survive, but under very exceptional, it should be really exceptional. Sometimes we can combine. But as a strategic, like if you are the architect and you are controlling the project, you have to be strong enough to tell everybody in your team that I'm not going to tolerate the fail-safe approach. This is these hot fixes and failing safe and making sure that all these components just live together, just survive together. This is not how we design systems. So you as an architect should be strong enough to protect your system against this surviving approach. So we can combine them, answering your questions. We can combine fail fast and fail safe, but fail fast should be 99% of your code. And maybe sometimes 1% you need to fail safe, but that should be exceptional situations and very specific places. Yep.
I have a question. Your approach is very convincing, but I would like to understand if final code won't be more complicated in your approach or not.
I think that's a good question. I think that in this way, in the fail-fast way, the code will be way less complicated. Why? Because this code will not have any logic which does not belong there. So this code will not know anything about potential abnormalities which are coming from there. So the problem happened here. The abnormality situation is coming from there, but I don't want to know about that. So my logic is focused only about what I care about. So which means that my code will be smaller and the complexity will be lower. So if you follow the fail-fast approach, I actually didn't mention that, but I wanted to, I forgot. So the entire complexity of the application will be lower if the fail-fast is the strategy. Because you always stay isolated. You basically don't help others. All you do, you just do your own piece of, you work only on your problems. You don't help other guys around you, other methods, other classes, other servers or microservices. You don't help them. You only focus on what you do and you do it the right way. In this case, the complexity of your code is lower because basically if something goes wrong, you throw exception. You fail here, you fail there. You don't care, you don't help anybody, you just fail. I don't like the format of the message, I fail. I don't like how you talk to me, I fail. You don't like the file which is saved there, I fail. That's it. So you don't try to survive, you don't try to fix the situations, you just fail, and fail. In this case, your code will be way smaller and much more cohesive. Probably that's the right word. So the code will stay together much better, stick together much better than if you fail safer and trying to help everybody. Because in this case, the logic is spread out. I think we had a question. Sorry, yeah. Go ahead.
As a support engineer, I'm like 7 years working as a support engineer. The idea is really great, but it's only great in theory. If like products which I was working with fail every time on any like exceptional situation, I bet that nobody in this room ever had a call through like mobile phone or something. In that way, I would like to disagree because we cannot split like engineering and business because business pays money for the engineers, right? If we will fail every time, the company will not exist, right? Do you agree with that?
100%. 100% I agree, and this happens because it's like, you know what, I have something on my skin, and I just put some zilonka over there. Instead of going to the doctor and do the surgery, so I don't want to do the surgery, I don't want to fix it, I just put this zilonka. and just, instead of fixing the problem, I just cover it with something. And then in the end, I'm full of this zilonka things everywhere. And I stop functioning normally.
And you die.
Yeah.
I totally agree with you in that point of view, but we just cannot say that once you had a pinch on your face, you need to run to the doctor to do the surgery on your face, right?
Yeah, you're right. In general, yeah, that's right. But I'm saying that it's happening. What you're looking at the end of the story. You just see the project, which is 5 years old, for example. 5 years old. We have a lot of code, a lot of engineers around. We just have problems coming in, and we just need to fix them fast because we can't just let the business, wait for this page offline for a day. But this is the end of the story. That's because us, the developers, the engineers, we're too weak or too stupid not to apply the fail-fast approach when we started that. So that's my problem. That's my point.
I totally agree with you, but the last phrase here, I think this is really good on the stages of the design and maybe first office assistance. But once we go for like operational, I think we should put this practice because people need the product, right? They need to use it sometime.
It's like chicken and egg problem. So if you have problems coming in, if you have bugs coming in and you have reports from the users and you keep fixing them with hot fixes, you will have more reports from the users. So it's like, it's just, you're basically gonna drown in the sea like deeper and deeper by this problem. They will just basically pull you down because, like deep inside. Because instead of fixing them right and having the enough, courage and be strong enough to say, guys, we just do it right. Just let's stop this whole system maybe for a few days and just fix it the right way. Instead, we keep surviving and surviving, and this surviving will lead us eventually to the complete disaster sooner or later. So it's like I say, chicken and egg problem. So if you follow the strategy from the beginning, then the operating side, when the system is operating, it will be way easier for everybody because everything will be isolated, like on this diagram. Everything will be in their own borders. Everything will be easy to fix. And every time we see a bug, we know exactly where the bug should be fixed. We fix it exactly there, not touching anything around us. That would be ideal world. Of course, we don't live in the ideal world. So of course, we are victims of our own weaknesses.
Last question. I'm here.
Okay. I think it's good for testing phase because your testers also should know where is the problem lay and what it's accordingly. But for real life, I think it's useless. But for example, do you have a dog?
A dog?
Yeah.
I have one.
Okay.
When I was
If the dog gets some disease, do you shoot the dog and buy another one? Yeah,
Well,
it's
I don't.
Really, so throw it away and give a better one. What else?
Well, if I would live in the ideal world, probably I would do that. But you know, I feel like some emotional attachment. Yeah, I feel love to the dog, so I kind of, you know, I'm a human being. But this is software we're talking about.
Okay,
right?
software. By you actually miss the file. Who cares? Do you know how to create this file or how to report this file? Or actually you can check if files exist before call the size function. Actually, it's not a deal for the size to check if file exists. Actually, you can check the existence of the file before calling the size.
Yes, you can. That's right. That's what we need to do. That's why we throw an exception to let my client know that it's your fault. You gave me the wrong file.
Yeah, but if you check the existence before calling the size,
Yeah, but this guy is not checking it for some reason. He's giving me the null pointer instead of a file.
yeah, but you just only message you can find the file. There is no approach for reception. It's no big deal actually. You can find the file at this moment, but you can find the file in a second or two. Maybe some network operation is not complete yet, and you suggest to go to application. I think it's fine.
We should discuss it after on the coffee break. But thanks for the question. I think we're out of time, right?
Yes.
Thanks for listening. Thanks for coming.
It was a great time.